Hi, everyone. Welcome to the Ransomware and Cloud Data Protection Summit. Today's event was organized by the hardworking folks at Virtualization Cloud Review and Redmond Magazine, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsor, Enterprise as a Backup as a Service provider, Clumio, for making this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of Application Development Trends, and I'll be your moderator for the first of 3 information-packed sessions. But before we get started, I need to go over a few housekeeping details. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our best to get to all of them. Our sponsor, Clumio, has provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. It'll be worth your while. At the end of this summit, you'll be asked to take a very short survey. Please take a moment to share your honest opinions. Our editors actually read every comment. I'm one of them, so I know. Your opinions help us to shape our future events. And last but not least, at the end of the 3rd session, one lucky attendee will be receiving a Surface Pro 7, Microsoft's ultralight tablet. But you must be present to win, so stick with us. And now let's get started with our first session, the top ransomware threats you're facing now. For this session, we've called on Alan Liska, intelligence analyst for Recorded Future. Alan has seen firsthand the damage ransomware attacks can cause and how ransomware actors operate and communicate with each other. He regularly appears on the PBS NewsHour, CNN, ABC, NBC, and CBS, and he's quoted in virtually all the leading print publications. He's also the author of let me get the title right, The Practice of Network Security, Building an Intelligence-Led Security Program, and also Setting NTP, a Quick Start Guide. I've attended another of Mr. Liska's sessions, and I know you guys are in for a good one. Take it away, Alan.
Thank you, John, and thank everybody for being here today. Very much appreciate the attendance, and looking forward to having a conversation with you all here. I will warn everybody, this presentation contains a lot of Simpsons memes, so I hope you all are big fans. I want to start with today talking about ransomware in the cloud. There's been a whole lot of discussion around ransomware in general last year and this year, understandably, because ransomware attacks have been on the rise. The ransomware attacks have gotten bigger, bolder, more disruptive, and it's a real problem. But one of the areas that's surprisingly under-discussed is how ransomware attacks on cloud surface, in the cloud environment and against cloud services have worked and how they've been growing during this time period. So what we're going to do today is we're going to talk a little bit about what kind of ransomware attacks in the cloud are occurring, how the ransomware actors are able to disrupt cloud services, including your own cloud services, and how you can protect yourselves from these kind of attacks. So it's a little bit different than what you'll see in most ransomware presentations, but again, this is an area that I think a lot of people aren't familiar with, and we want to make sure that that you understand what the threats actually are. So when we talk about ransomware threats to the cloud, we're really talking about 3 different kinds of attacks, 3 different types of attacks. Ransomware attacks against cloud infrastructure directly, against managed service providers, and the growing interest amongst ransomware groups in attacking ESXi, so VMware's virtualization service. And we've seen this over the last year. We've seen the interest in ransomware specifically going after cloud service providers. And when we talk about cloud service providers, what we're talking about generally are hosting companies and cloud-specific providers. And we've seen a growing number of attacks against these particular companies and against these particular services. And the appeal is fairly obvious. If you're a ransomware actor, I can knock over a company and potentially get a ransom from them, but maybe not. On the other hand, if I knock over a cloud provider, if I'm able to encrypt a cloud provider's infrastructure, then what I have is I have not only the cloud provider as a potential victim, but all of the cloud provider's customers as potential victims. So, and that is why there's this growing desire amongst ransomware groups to go after. They're already going after bigger and bigger targets, but now they're focusing on the service providers as a way to increase their chance of getting paid ransom. We are used to, generally when we talk about ransomware and cloud, we're used to talking about how the cloud is used to distribute ransomware. So, for example, we see ransomware groups use Office 365 or Google Docs or Dropbox as phishing lures. That's one way that we've seen ransomware in the cloud talking about. But these are used to either gain access to a target organization or they're used to grab credentials. So you have a fake Office 365 form, you put in your network username and password, and now the ransomware group has authentication for credential reuse or credential stuffing attacks. But what we're talking about in this case is we're actually talking about ransomware groups going after cloud services directly. So going back to the chart that I showed a couple of slides ago, between August of 2020 and August of 2021, we recorded 89 publicly reported ransomware attacks against cloud service providers. Now, publicly reported attacks make up only a small fraction of the total number of ransomware attacks, but still 89 attacks against cloud service providers is significantly higher than we've seen in any period prior to this. So this, again, it shows a maturity of the ransomware actors, and it shows where they're starting to focus their attacks. So ransomware groups are looking for ever larger payouts, and encrypting data in a cloud environment is one way to do that. Holding data stored in the cloud hostage gives the ransomware groups the chance to extort not just the cloud provider, but their clients, and they're able to start that process over again with secondary extortion. So most ransomware groups now don't rely just on encrypting their files, encrypting a victim's files, and hoping that that's enough to get the victim to pay. Instead, what they also do is they look at most ransomware groups have what we call extortion sites or leak sites, where while they're in the network before they deploy the ransomware, they steal files and they publish that on their leak sites for victims that refuse to pay. So if you're a cloud service provider, you may be able to recover from a ransomware attack, and you may be able to recover relatively quickly. So you're able to get everything back up and running, and there's no problem. But then when that secondary extortion comes in, you now run the risk not just of revealing your own sensitive data, but possibly your client's sensitive data. And so, again, ransomware actors see that as a definite avenue for increased increased likelihood of payout. And ultimately, that's what they want, right? They want to make as much money as possible, and they want to increase their chances of making money. So if you're not worried about your own data being published to a ransomware extortion site, then maybe you'll be worried about your client's data being published and losing those clients if that data is published. Not quite the same thing, but we saw this with the Kaseya attack in REvil, where the fact that Kaseya was used as the method for pushing the REvil ransomware down meant that some MSPs started immediately looking for another RMM solution, another remote management and monitoring solution, because they didn't have a lot of confidence that Kaseya would be able to fully recover and fully patch the software. So again, these kind of attacks against cloud providers are a bigger problem, are exactly this kind of problem. So again, when we talk about this, ransomware groups are increasingly relying on double extortion and especially targeting cloud providers. This threat is effective, not with the data, but the clients as well. And in fact, what we've seen a few times is not just the double extortion, but some of the ransomware groups, because remember, ransomware groups have a lot of money. The biggest ransomware groups have made hundreds of millions of dollars over the last year. So we actually have seen a few ransomware groups that will rent out space at a call center or contract with a call center. And so if that double extortion isn't working, they will use the fact that they've stolen the client contact information from the cloud provider, and they'll use the call center to start calling the customers of the victim to say, hey, we've stolen your data. We've published it on our ransomware extortion site. Your cloud provider X refuses to pay. You should call them and tell them that they have to pay the ransom. So again, this is a real challenge for cloud providers and their clients. And we've seen these over and over again, where NetGain was a very big one that was hit. There was a Swedish cloud provider that was hit. Like one of them got hit with ransomware, or managed to stop the ransomware attack. They couldn't stop the data exfiltration, so they had to pay to make sure the data wasn't published. And of course, the problem with that, and John and I have discussed this ad nauseum, ransomware actors are lying bastards. When they say that they've deleted the data they've stolen from you, most likely they haven't deleted the data they've stolen from you, and you can assume that will still at some point end up on an underground forum or being sold or repackaged in some other way. So you're really running into a big problem. But again, we've seen this growth in attacks against cloud providers and this increasing sophistication of ransomware groups and knowing to go after these cloud providers. And unfortunately, that's a trend that is going to continue. We also see managed service providers are frequently targeted by ransomware groups. So this has been true for several years, starting with the Southern Akibi ransomware. One of the first big attacks from Southern Akibi, also known as REvil, was against a managed service provider in India. Southern Akibi was also responsible for the ransomware attack in Texas, where a Texas MSP was compromised, and that was used to push out the ransomware to 23 towns in Texas in 2019. So we knew that this was a type of activity that ransomware groups were very much interested in. And then, of course, earlier this year, we saw the Kaseya ransomware attack. And that was sort of successful at first for the REvil ransomware group. It was one of those things where they had success, but then they also failed miserably. But it is definitely, it got the kind of attention that we don't want these kind of attacks to get. It's really set off a firestorm of ransomware groups and ransomware discussion areas looking specifically at MSPs as a potential target. And again, we'll see even more of that coming up in the future here. So the Kaseya ransomware attack set a new standard for ransomware attacks against MSPs. REvil either bought or had a zero-day vulnerability against the Kaseya virtual system administration software, and that allowed the REvil affiliate to exploit multiple MSPs. So multiple MSPs that use the Kaseya VSA software, and then from that exploitation, they were able to use the Kaseya VSA tool to deliver the ransomware. So Kaseya wasn't infected by REvil. The MSPs weren't actually encrypted. So the ransomware actor, the ransomware affiliate, didn't actually encrypt the MSPs. Instead, they used the software to push down the Kaseya VSA software to push down the ransomware to the MSP's customers. And that's just a clear delineation that we want to make, is that oftentimes MSPs are targeted not because the ransomware actor wants to encrypt their networks, but because they want to use that to gain access to their clients. So around 1,500 organizations and hundreds of thousands of machines were encrypted over the course of roughly a 24-hour period. Somewhere between 8 and 10 of the MSPs were impacted by this. And so the problem is that remote management monitoring tools have been the focus of ransomware groups for years. This is, Nikibi, again, has used this multiple times, but there are other ransomware groups that are specifically going after these remote management and monitoring tools, because ransomware groups have found that once you gain access to these tools, you basically have unfettered access to the victim networks. You land inside the middle of the network, and you're able to deploy the ransomware everywhere, because generally speaking, these tools need to have insight, need to have an overview of the entire network. And again, we've seen repeatedly where ransomware actors are learning more and more about RMM tools, looking to buy vulnerabilities in various RMM tools. And again, we're talking about ransomware groups that now have hundreds of millions of dollars at their disposal. Some ransomware groups are better funded than some nation-state actors. And so they are active competitors in the zero-day exploit market. So in the market for buying vulnerabilities that aren't publicly known about. And that's a really scary proposition for a lot of these, for the manufacturers of these RMM tools. And it's also a scary proposition for clients of these MSSPs, or for these MSPs, and they may not realize that it's a scary proposition, because most of the time it's small to medium-sized businesses that are using these MSPs. They don't necessarily have the protections in place. They don't have the IT or the security staff in place, which is why they contract out to an MSP. So they're completely trusting the MSP, who in turn is completely trusting this remote management, monitoring and management software. And so you have this sort of chain that if a ransomware actor gets a vulnerability, is able to gain access, gets a zero-day vulnerability and is able to gain access, they literally have unfettered. They literally have the unfettered ability to deploy ransomware across, hundreds, if not thousands, of victims simultaneously. Which, again, we saw that with Kaseya. The next attack could be even bigger than that. And MSPs broadly have been a large target. So in 2019. There were more than there were roughly 100 MSPs that were hit with ransomware. Again, these are publicly reported. The real number is probably higher. And then in 2020, we saw even more that were hit with and more MSPs that were hit with ransomware, again, publicly reported. And we're seeing the same thing repeat itself in 2021. Ransomware actors are very much interested in MSPs as a potential target. And again, just like with the cloud providers, they want access, the ransomware actors want access to client data and the client networks. So some MSPs hold sensitive client data. A lot of clients use their MSP as a backup service, so that they handle the backups for the clients. Others are specialize in other types of services for the clients. So they want that client data. They also want access to the client networks. And again, especially MSPs that focus on the smaller clients have the clients don't have the IT or security staff to protect themselves from this kind of attack as it comes up. So we're seeing this grow, and unfortunately, I think we'll continue to see it grow. And again, this is a new method for ransomware groups. So ransomware groups had used exploits for a long time. They used exploits to go after Citrix servers, to go after VPN concentrators. They'd used the zero login exploits, and once they've gotten inside the networks. So ransomware actors have used exploits for a while. What sets this apart is this was a true zero-day. So we've seen ransomware actors use exploits against known vulnerabilities that we hadn't seen exploits for before. This is the first time that we've seen an unknown vulnerability with the ransomware actor producing the exploit for it. But it's not going to be the last time we see that. And with that reliance that MSPs have on this remote monitoring and management software, all the different versions, and ransomware groups actively looking to purchase vulnerabilities against these types of tools, we do expect to see more of these attacks going forward. And I promise this is the last Simpsons meme for this presentation. Not embarrassed about all the Simpsons memes, but, I know they're not for everybody. The last thing I want to talk about is ransomware and VMware ESXi. This is a relatively new turn for ransomware groups, but again, it makes sense. As they've gotten better at what they do, as they've been able to start collecting more information and go after bigger networks and be more destructive in their attacks. This is the kind of evolution that we see in ransomware groups. And what I want to show in this chart is how quickly we went from ransomware groups looking for vulnerabilities in ESXi. So this is all from August to August of 2020 to 2021, or excuse me, from March to August 2021. So back in March, discussion started happening that ransomware groups were exploiting known vulnerabilities in ESXi, and that's still the case going forward. So they were actively trying to gain access to ESXi servers. And now we've gone from that in March to now August. We know that there are several ransomware groups that have ESXi-specific variants of their ransomware. So that means that they're able to gain access to unpatched ESXi servers, and then once they gain access to those servers, they're able to encrypt everything on that server, which means all the VMs that are on that server become encrypted. So again, this is ransomware groups advancing their tactics, getting better at what they do, knowing that they have to do, they have to be able to encrypt these types of virtual machines in order to fully disrupt the network. Because the more disruption they cause, the more pain they cause, the more likely they are to get the ransom from the victims. And being able to encrypt an entire ESXi server and all of the virtual machines on it in one fell swoop, rather than having to log into each individual one, means that they can operate faster and create more damage. And unfortunately, again, that's what we're seeing with these kind of attacks. So specifically, ransomware groups have been exploiting vulnerabilities in ESXi servers, specifically CVE 2019-5554, CVE 2020-3992, and CVE 2020-4004. Those are the big ones that we've seen. There may be some others out there that I'm not familiar with, but these are the big vulnerabilities that are being exploited. All of these are remote code executable vulnerabilities, which means that once they exploit it, they're able to get access to the servers and start moving around the servers. So they're not exploiting unknown vulnerabilities. This is not a zero-day situation. They're exploiting known vulnerabilities that proof of concept code has been delivered for. What is new is they're very quickly weaponizing that proof of concept code, incorporating that into their operations and doing this. In particular, one of the things that's scary about this is that a lot of organizations use ESXi as part of their disaster recovery plan. So what they'll do is they'll have copies of servers and other things stored on ESXi servers so that if their main server, so if their Exchange server, for example, gets encrypted, they can quickly spin up a new Exchange server and keep operations running. Well, again, ransomware actors know that, and as long as that disaster recovery network is connected to the primary network, they're able to find it and they're able to encrypt those servers so that when you try and activate your disaster recovery plan after a ransomware attack, you'll find out that those machines are no longer accessible, which is a real problem. Again, a real problem in trying to recover from the ransomware without paying it. Several of these ransomware groups have developed variants specifically for ESXi, so Babook, Black Matter, Hello Kitty are some of the groups that have ESXi variants. There are others out there as well, and more groups are adding this capability. One of the things that is really concerning, on top of all of this being very concerning, is that these variants don't always, they encrypt very well, but the decryption process doesn't always work. So I've been involved in a number of incident response attempts where the victim wound up paying the ransom, got the decryption key, and found out, got the decryption tool and found out that they couldn't decrypt the virtual images, the virtual machines on the ESXi servers. Part of that is file size. A lot of ransomware groups have decryption tools to choke on large file sizes. But part of it is that while they're learning about ESXi and virtual machines, ransomware actors are most definitely not experts in that area yet, and so they write crappy code. Excuse me. Now, fortunately, in every case, there was an incident response team there that was able to use the key that came in the decryption tool given to the victims, and was able to write a better decryption tool. And honestly, that's almost standard protocol at this point. Universally, it's fairly well known that decryption tools given by ransomware actors almost always are bad and need to be rewritten. So similar to cloud providers and MSPs, ransomware groups know that victims also often store sensitive data. So even if you're not using your ESXi for disaster recovery, in general, organizations that maintain their own data centers are storing sensitive data on these ESXi servers. And so if you encrypt these systems, it means that the ransomware group is able to encrypt multiple servers all at once, and lock up even more of your sensitive data. And they don't have to now do it file by file and file, which increases their chances of being detected. So organizations, so again, the ransomware groups are going out of their way to make sure that that they are looking for these ESXi servers, properly encrypting them, and basically taking as much of the network offline. Again, the goal is to inflict the maximum amount of damage and make it much more likely that the victim will pay the ransom, which is why it's really important as part of your normal routine, your normal workday, that ESXi servers be prioritized for patching. So right now, again, we're not seeing any ransomware actors use 0 days against ESXi servers, and they're still learning how virtual machines works, how ESXi set up. They don't quite fully understand it. So having those machines patched is really, really important. You want to prevent that access in the first place. You don't necessarily want to give a ransomware group, make it easy for them, in other words, to gain access to ESXi servers. You make sure that you're keeping a backup of all the images that you have on your ESXi server. I mean, which may seem odd. Like, if you're using it for backup or using it for disaster recovery, why would you have another backup somewhere else? But you almost have to do that so you're able to fully recover your ESXi. And if you are using it for disaster recovery, bring it up for when you need to duplicate and when you need to make changes, and then shut it down again so that it's not a target for ransomware actors. So these kind of changes will allow you as an organization to, again, better protect yourself from ransomware actors. As they are going to get more sophisticated, they are going to get better at ESXi. And the challenge is, because of the affiliate model that so many of these ransomware groups use now, where it's not the ransomware group, but it's one of their affiliates that are launching these attacks. As the affiliates learn from their mistakes and learn, more about how ESXi and these other type of advanced networking services work, they're sharing that information with the other affiliates. And then as ransomware groups, as a ransomware affiliate moves from maybe one ransomware group to another ransomware group, they're taking everything they learned from the first ransomware group and sharing it with all the affiliates in the second ransomware groups. So as every ransomware affiliate learns more about how these tools operate, they're sharing that with all of the other affiliates, basically making everybody better at their at conducting ransomware attacks, which to me is really scary, because you now have a cyber criminal force that is increasingly advanced and benefiting from the fact that they've now engaged collectively in tens of thousands of these hands-on keyboard ransomware attacks. And so that body of knowledge is unfortunately built up pretty significantly. So I'd love to answer any questions that everybody has. Again, I really appreciate everybody's time today. Hopefully this has been an interesting conversation, and again, happy to continue.
Thank you, Alan. Wow. I don't know if I'm ever going to sleep again. This affiliate model is just absolutely fascinating. It's like an open source ecosystem, like for Java or Linux. I mean, that's going to, as you have mentioned, that's going to make them even more dangerous, even more powerful. It's amazing.
Yeah, it absolutely is. And, it really becomes that force multiplier where you're not defending against one ransomware group, you're defending against hundreds of ransomware groups, across a collective of all of the different types of activities and, initial entry vectors and all these other things.
Oh, my God. Just amazing. Also, I hadn't heard the call center thing where they can take ransomware and then there's a little blackmail element added to the formula.
Right. Well,
Okay.
I mean,
All right.
It's amazing the things that the ransomware actors will do. We've seen like the Black Matter ransomware doesn't just do ransom notes. They also send the ransom notes to every printer they can find in the network. So they're printing out the ransom notes as well.
Oh, that must be just a horrible experience. Huh. Well, enough of my babbling. Let's get to some of the questions from our attendees. Remember, guys, you can type your questions into the Q&A box at any time. We'll do our best to get to all of them. Okay, let's grab this question here. How many companies recovering from ransomware how are companies recovering from ransomware in the cloud? Physical recovery is the way I have normally recovered when we get hit.
Right. So that is part of the problem. Is that most organizations don't actually plan for their cloud providers to get hit with ransomware. So what I tell people is you have to start thinking about where your data is stored, because all of us now have data stored in various cloud providers, right? Like how many organizations could imagine Salesforce gets hit with a ransomware attack at the end of, the fourth quarter, right? Late in December. How much damage would that cause to so many organizations around the world when they couldn't close out their fourth quarter deals because everything was in Salesforce? So one of the things I tell people is you need to understand what data your cloud provider has. Whenever possible, you need to be able to make a backup of that and then have a plan for how you're going to assess that, address that. And it's hard because you can't necessarily force your cloud provider to make changes, but you can at least through surveys and through third-party intelligence be able to assess how secure your third-party provider is and know how extensive your backup plans need to be if that provider gets hit with a ransomware attack.
Wow. Okay, here's one. What is a good way to protect your data that is in the cloud? Example, M365, Microsoft 365. Do you suggest local backups of email, etc.? I think you might have answered this already, but maybe take another whack at it.
So yes, whenever possible, absolutely make backups. But the problem is, let's say that you're even 1,000-person organization, trying to back up your cloud provider, like the mail server from your cloud provider. That is a real challenge. If you can do it, yes, absolutely. I also recommend, and I know people hate this because it's such a bear to manage. If you can do multi-tenant or multi-cloud provider or multi-cloud infrastructure, that's always better, right? If you can store your data, it doesn't necessarily work with your mail server, but with other types of data. If you can have the data replicated across multiple cloud providers, that is great, as long as there's no easy way for the ransomware actor to get from one cloud provider to the other. If there's an SSH connection or something or a VPN connection that the ransomware actor can quickly jump across, then all that means is your data is going to be encrypted in both clouds. So if you can back it up, yes, do that. If you can duplicate it, even better, because then you don't go down at all. Worst case scenario, have a plan for what's going to happen when that's recovered, how you're going to continue business operations.
Okay, here's one that's relates to a timely news topic. The President Biden just had several technology CEOs along with financial, healthcare, and other industries met with them to discuss and develop a national ransomware solution. What are your thoughts on this? And if this approach is possible, and if it is, how do you see it unfolding for the U.S.?
Yeah, I try and remain as apolitical as possible, but I will say that I've been really impressed with what the Biden administration's been doing in terms of combating ransomware. It's not everything I would have wanted, but I feel like I'm the anti-ransomware lobbyist, and I got my whatever $1 million worth. You need to have a public-private partnership. The fact is that private organizations, private companies, Microsoft, Mandiant, CrowdStrike, all have way more data about ransomware attacks than most government agencies do. Most people don't want to reach out to the government when they've had a ransomware attack. So, I know the FBI and CISA say, yes, definitely call us if there's a ransomware attack, and we'll come to help. Most people would rather call Mandiant or CrowdStrike to deal with that. Mm-hmm. So you need to have that public-private partnership, because there are things that the government can do that private businesses can't do. Yes, the private businesses can say, hey, here's all the things we're seeing with ransomware attacks. Here's what organizations need to do to defend themselves. But then the government can do things like ransomware takedowns. Again, mm-hmm. We've not seen this before this year, but so far there have been 11 different ransomware groups that have either, because of law enforcement, been forced to shut down, or because of law enforcement activity decided it was time to retire, in air quotes. Either way, that's good news. Now, the problem is you're basically playing whack-a-mole, because 11 shut down, 11 new ones start up, because ransomware is so profitable. But we haven't seen this kind of concerted government action, and it is having a real impact on ransomware groups. Many of them have decided it's not worth the risk. Again, that doesn't change the fact that new people are popping up all the time. So, but it's a start, right? You're not going to get it right perfectly the first time, but we are seeing movement in the right direction.
Okay, we got it. The questions are coming in hot. Let's see here. Let's do a simple one. Any signs Hyper-V is being targeted as well?
No. And if you're a ransomware actor listening, please don't. We're not offering suggestions here. I always hesitate to say, hey, why don't ransomware groups do this? This would be easy, because then somebody will pick it up and they'll start doing it. But no. Despite the fact that we have seen over the last year, we've probably seen 4 or 5 remote code execution vulnerabilities against Hyper-V. What we haven't seen is any proof of concept code released for those, mm-hmm. and knock wood, obviously. Mm-hmm. And generally, ransomware groups are looking for somebody else to release proof of concept code before they try to incorporate it. So we haven't seen it. That doesn't mean that we won't, and you shouldn't assume, oh, hey, I'm using Hyper-V, so I'm perfectly safe. Obviously, that's not going to be the case. But it has not happened yet.
Okay, I'm going to paraphrase this one just a little. Let's see here. Once you've been exposed to ransomware, will future attacks be easier for hackers to infiltrate, I would say perpetrate, since they know that you are vulnerable? Once you get hit, do you stand out like, an easy target in the future, I guess?
So it depends on your response. It depends on how you handle mm-hmm. IRs. I tell organizations when I walk in an incident response is, I know that what the CEO and the board want is for you to get the business back up and running as quickly as possible. But I've seen too many times where if you don't figure out how the ransomware actor got in and plug that hole, whether that is a vulnerability that was exploited or whether it was a phishing attack that wasn't stopped properly, whatever that vulnerability is, if you don't fix it, you will get hit again, and you will get hit again very quickly. Generally speaking, about 80% of victims, about 80% of victims who are hit with ransomware see another ransomware attempt within 2 weeks. So whatever vulnerability was found, somebody else finds it and tries to execute it. If you block that vulnerability, if that is the first thing that you do is get that vulnerability blocked, or among the first things that you do, you are significantly less likely to get hit again.
Fascinating. Let's see here. There's another straightforward one. For SMBs, does SD-WAN type security solutions provide a sufficient protection?
I'm sorry, for what kind of security solution?
SD does. I'm not sure what this is. The SD-WAN. I don't know what that is.
Yeah, SD-WAN. Yeah, absolutely. That is. No solution is perfect because no solution is perfect because you have humans implementing it. So I don't want to say yes. I don't want to say no because it can when it's implemented properly, but it is one of those things where you do have to implement it properly, and you do have to you do basically want to use it to properly segment off your network to isolate the different systems, and that'll help keep you protected from these from some of these ransomware attacks.
Fascinating. What is the most common security breach in today's business network?
So overall, the most common one is a phishing attack. For ransomware, it's interesting because it varies between, depending on the month and the quarter and so on, it varies between phishing as the most common point of entry and remote desktop protocol. So people don't realize that it's expensive to rent phishing infrastructure. If you are a new ransomware actor or you're new an initial access broker just getting out, just getting started, renting phishing infrastructure and sending out phishing emails can be relatively expensive. It doesn't cost you anything at all to scan the internet for open remote desktop protocol servers and then just try password reuse or password stuffing attacks against those servers that you found. So you can very quickly, using a tool like Masscan claims that it can scan the entire IP4 address space in under 6 minutes. I don't know if that's true, and it certainly isn't true on the crappy laptop that a new ransomware affiliate is going to be doing it from. But you can scan hundreds of thousands of IP addresses very quickly, get a list of potentially vulnerable systems running remote desktop protocol, and then start with your password stuffing attacks. The tools are free, they're easy to use, and so that's why we very often see remote desktop protocol being the primary point of entry for ransomware groups.
Fascinating. Okay, here's one. Wouldn't companies and government agencies need to have good observability and SOC automation to help identify early when issues are getting started? Seems like AI, i.e. Sumo Logic, would be able to help see an attack coming early and find out what issues need human attention.
Sure. So visibility is overall a problem for many organizations, right? I mean, that's, I think, and it's weird, John, you and I have been doing this for a while. We've been talking about the problems of visibility and network asset management and patch management for 20 years, and we still haven't figured out how to solve that problem, right? But yeah, so again, we go back to remote desktop protocol as an initial entry point. I've talked to many clients who have said, we don't have any remote desktop protocol servers exposed to the internet, only to find out when they do an external scan that, oh, hey, we had 5 of them. 3 of them, we don't even know what these systems do anymore. So asset management is a real problem, as is patch management. And that's sort of the start of the network visibility problem. But then, yes, ransomware groups don't do anything unique and groundbreaking once they get in the network. They disable the whatever antivirus or endpoint protection you have. They try to get access to the domain controller, and then they use the domain controller to push out the ransomware. All of these steps can be checked along the way. So you should get an alert. You should get a sort of a hair on fire alert when your endpoint protection is turned off on an endpoint, right? But for many organizations, they don't. You should get an alert if somebody is using PSExec in your network and it's not a standard PSExec. You should get an alert when there's a password stuffing attack against your Active Directory controller. All of these things should generate alerts that would cause you to stop. That would cause you to investigate and potentially stop a ransomware attack. Too many organizations don't do that. But you have to know how the ransomware actors operate, what tools they use, and you have to have those protections in place. And more importantly, you have to have somebody monitoring for these things, these activities, these events on your network in order to be able to respond to them.
Okay, here's a long one. I was a solution architect for a client in Arlington, Virginia, successfully as a carbon black engineer before VM acquired the company. Today, is it possible to regain full control without attaching to the VMware cloud infrastructure? That local level of control was ironclad for high enforcement without any vulnerabilities to mitigate.
That is a really interesting question. And I'm afraid I don't know the answer to that. I don't want to speak out of turn. I think the answer is yes, but I'm not 100% positive. VMware Cloud is absolutely becoming an integral part of any VMware solution, so I don't know if it fully is. But yes, that absolutely right. If you have an entirely local installation and you have high enforcement, you definitely have much more control, and you're much more likely to get hit by a ransomware attack. And of course, that's true with any kind of technology where the higher the security level that you've enabled, the less likely a ransomware actor is able to get access to it. The problem is that oftentimes those high level of enforcement serve as an inconvenience and business disruptor, and that's why they often get turned off. There's a reason why most organizations don't opt for the most secure version of every tool that they use. It's because it tends to interrupt business, and it makes it harder for people to actually do their jobs.
Fascinating.
But that was a really good question. I wish I had a better answer, but it's not something that I know for sure.
Okay, here's one. We keep talking about securing the endpoints. Why aren't we shifting / including the carriers, ISP, domain registrars, hosting providers in this responsibility?
I don't think that we're excluding them. What we're saying is we can't necessarily count on whatever security measures they have in place. It's hard for example, an ISP to control, to stop people scanning or launching brute force attacks, because they can only do so much. There's so much traffic going across the network that even somebody who's doing very loud scanning is going to blend in across the billions and billions of other packets. We are seeing some improvements in some of the hosting providers that are often used as redirects for these ransomware groups. So, ransomware groups don't launch their attacks from Russia. They compromise systems in the U.S. and then redirect from there. And we've seen big steps from companies like AWS and Microsoft Azure, DigitalOcean, and some of the others for trying to detect intrusions on their systems without interfering with their clients' day-to-day operations, which is always a delicate balance. We've seen that, and we've even seen some, domain registrars gotten better. Like, Namecheap, for example, used to have a really bad reputation. They've really turned it around in terms of being very proactive and taking down malicious domains and doing it very quickly.
Fascinating. Okay, here's a short one. Are government or commercial businesses targeted more?
Good question. Generally speaking, ransomware groups don't target, period. Like, they don't target sectors. What they target is vulnerabilities. So if a ransomware actor is good at going after remote desktop protocol, doesn't matter if you're a government or a private entity, if you have vulnerable remote desktop protocol, they're going to hit you. If they have a false secure VPN exploit, doesn't matter what you're running. If you have that, then you definitely they're coming after you if you haven't patched it. So overall, because there are more private entities than governments, there are more private entities that get hit. And there are some ransomware groups that if it's a certain type of private entity, they will back off even if they've figured out what they've gotten into. But that is really, if they say they do that, they don't always do that.
Okay, this one's more of an observation than a question. The best defense is to encrypt the device because ransomware can't take the device that has BitLocker engaged. Is that right? What do you think about that? So
I think it depends on the encryption tool that you're using. So remember, when the ransomware actor gets access to a network, when they get access to a specific system, they often get access with admin credentials. That's one of the first things that they try and get. And when they have admin credentials, they can unlock that drive, so they can unlock the file. So some tools are better at preventing that activity than others, but you have to be careful. You can't just assume that because my data is encrypted at rest that the ransomware actor won't be able to decrypt it before they exfil it. And if they encrypt an encrypted file, it's still encrypted. So yes, it might prevent useful data exfiltration. You still have the problem of your entire drive still being encrypted.
Wow, where did the time go? We're nearing the top of the hour. Looks like that's all the questions we have time for. Alan, thank you so much for a great session.
Hey, no problem. Thank you as always. I really appreciate the chance to chat with you, John, and I love the fantastic questions we get from the participants here. So thank everybody for their time today.
We got some great questions. If your question wasn't answered, we'll take a look, and I think Alan can get back to you later via email. Okay, we're going to take a short break, but we'll be back at the top of the hour for our second session. Cloud data protection, best practices for AWS and Azure, led by Joey D'Antoni, principal consultant at Denny Cherry & Associates Consulting, and moderated by my colleague David Rammel, the driving force behind the must-read reporting at Virtualization and Cloud Review. Many thanks to Alan Liska for a great session, and to our sponsor, Enterprise Backup as a Service, Clumio, for making it possible. Now would be a great time to check those extra resources on your console provided by our sponsor. I'll be back to moderate the third session and give away that Surface Pro 7 to one lucky attendee. Remember, you must be present to win, so stay tuned. Back in a few.
Okay, welcome back, everyone. Thank you for being here. Thank you to our speakers and, of course, our sponsor, Clumio, for underwriting the summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization and Cloud Review, and I'm here to moderate the second session of our summit called Cloud Data Protection Best Practices for AWS and Azure. Our speaker for this session is Joey Biantoni, Principal Consultant at Dating Cherry and Associates Consulting. Joey is recognized as a VMware V expert and a Microsoft Data Platform MVP, and he has over 20 years of experience working in both Fortune 500 and smaller firms. He has worked extensively on database platforms and cloud technologies and has specific expertise in performance tuning, infrastructure, and disaster recovery. Joey, it's great to have you here. Please take it away.
Thanks, David, and hi, everyone, and welcome to Cloud Data Protection Best Practices for AWS and Azure. It's funny, this morning I just had a call with a customer, about an hour ago, actually, discussing various hybrid technologies, and there are a lot of challenges in the space, and there are a lot of unknowns, and you really want to make sure the vendors you're working with have a good understanding of the cloud you're going on, because that's a lot of the issue there. This morning I was just managing through a project where the vendor had kind of made some promises around being able to do things in a cloud native fashion, where they were going to be able to restore backups natively to it was Azure in this case. And in the end, they kind of came back to my customer and said, hey, we can only do this if you buy VMware and run that in Azure. So you really want to have a good understanding of your data protection. But we're going to talk about a number of topics today. And I kind of like to break these down to start with security and then kind of work backwards from there. Because I think security is part of this, but we also have how we protect our data in terms of understanding what our data is and how we protect that data. So we kind of like have this multi-layered onion model, starting with the network, and then down to the host, the application, and then the data that we deal with. Where I kind of live, and I live on kind of two sides of this. I live a lot at the network side, because a lot of what I do in my job is cloud architecture. So I help people design their cloud infrastructure, whether that be platform as a service, infrastructure as a service, or even in some cases software as a service offerings, and how those things interact. When we first talk about isolating the network, we don't really talk so much about physical hosts on the cloud, but one of the things we really do talk about is the control plane, and that's going to be a lot of our security wrapped around, and we'll talk more about that in detail. But effectively, by default, if you're using Azure or AWS, it's almost like you have your VMware vCenter, or really the doors to your data center open to anybody who can authenticate into your cloud on the internet, which is a little bit scary, especially after hearing the last presentation about all the various attack surfaces that are out there. So you want to think about how to protect that. And then when we get down into Applicata and data, you want to think about how to best protect those. One of the pieces of advice I give a lot of my customers, and some of them take it, not all, but particularly for their database servers, is if you can help it, there's really no need to back up your database servers in the cloud. And hear me out carefully, because I would shoot me if I heard somebody else say that. You want to back up your databases. And so like with SQL Server, if you're in Azure, there's a backup to URL feature, which means you can back up directly to blob storage. And you don't have to store that data on a file system somewhere. It's stored in cloud storage that can be immutable depending on what you're doing. Immutable means it can't be written over again. And by having that there, you're kind of reducing your backup cost. And the cost of acquiring a new VM is extremely low in terms of recovery time. So it's actually, in a lot of cases, faster to spin up a new SQL Server VM and restore your databases to it than it is to try to restore the entire VM. So just a couple of things to keep in mind there. So we start out with security, and well, there are a number of security challenges in the cloud, and I remember like having this discussion with way back when I was first consulting. I had a customer who had a database that was like a really good fit for a platform as a service database, who talked about how they couldn't go to the cloud because of security, and then the customer walked me through the unlocked door into their data center, which was just an extension of his office. And it didn't actually have any fire controls or security controls or any controls really at all. So that's kind of one of the things that you don't have to think about with the cloud. all Azure, AWS, Google Cloud data centers are all tier 1 data centers that have pretty extreme physical security requirements. Nobody's sneaking into the building and stealing the servers that you're on. So the cool thing is you don't have to think about physical security at all. So you can kind of just wipe that thought out of your head. That's all handled by the provider. And the providers all mention, the shared balance of security. They're responsible for some of the security, and you're responsible for some of the security. The cloud has a lot more security features. There's a lot, and this goes for AWS or Azure. There are a lot of things you can configure. You can configure private networking to platform as a services. Different services have different kinds of architectures, and that's one of the things that's really challenging to understand, because the way you configure private networking for one service might be different than the way you configure private networking for another service. I was doing something in AWS last week, and I know there are a number of data breaches around having exposed S3, which is their storage service, buckets to the internet. Like numerous data breaches have happened because of that. But when you go through trying to configure AWS S3 security, it can be frustrating, and I can understand why people just make it publicly available, because it's not super easy. So as you have these deeper and deeper security features, and some of them get more and more complex, and that responsibility I kind of put on Microsoft and Amazon. But it becomes easier to have misconfigurations. Like, I was troubleshooting the other day, and I couldn't get it to work. And I'll admit this, even though I would criticize anyone for doing it, including myself. I knew I wasn't going to have sensitive data going to this account. It's a demo database from Microsoft that I was writing to an S3 account. And in order to just get it to work, because I was trying to repro a customer environment, I turned on public access to my S3 bucket, and I'll hang my head in shame now. But it can be frustrating. So the other thing to note is, as you migrate into the cloud, your IT staff and your developers might not necessarily have the deep understanding of the cloud services that they had, in their on-prem world. So it becomes easier and easier to make mistakes. The second part of this is it's really important to understand your identity and control plane. I mentioned this a little bit on the last slide, but if we think about what our cloud, whether it's the Azure portal or the AWS console represents, that's effectively like having your VM or vCenter published to the internet. This is just kind of a function of the cloud, and there are some things you can do around that. Like you can limit the number of IP addresses that can connect to it. So you can require people in your organization to be on your network to come in, which is a pretty common thing I see. You can require multi-factor authentication. I shouldn't say can. You absolutely must require multi-factor authentication. It's not going to force you to, but it's something you definitely want to do for access to the control plane. I know in Azure there's a feature called conditional access, and that's one of the things we have set up in our Azure tenant is if you're accessing the Azure portal, you do have to multi-factor off just to provide that additional layer of security. The other thing you want to understand when you're in the cloud is the identity solution. So Azure and Amazon are a little bit different in how they handle this, but fundamentally they're the same. You kind of have users in your directory, and then you also have services that have identities, and you can grant permissions or IAM roles to those services, and they can have access. And how that all plays with your different application stacks is something that you want to really carefully evaluate. Once again, if you're looking at this from like an audit perspective, you always want to look for things that have pretty high privileges. I know in Azure and Amazon, they both kind of have security scores that they'll give you. And one of the things they'll look at for is overprivileged accounts. So if you have those accounts that have really high privileges because somebody was just trying to make it work, or the baseline permissions were just set too high by the service, those are kind of things you want to look at for. And then finally, there's a lot of increased complexity as you mix different types of services and providers. I mentioned different configurations for different types of platforms as a service offerings. It's really important to kind of understand, and especially if you have a security team, to work with the rest of the IT org to understand what people are deploying. and then how you can deploy that in a secure fashion to meet whatever regulatory requirements you have. Because different types of services are secured in different ways. They're different. There's a whole bunch of stuff. There's different levels of security that's required based on the type of industry you're in. So tying all those things together is a real responsibility for an IT organization. And security, as always, is like underfunded because, nothing happened last year. So why do we need that security line item? So how we protect data in the cloud. What we wanted to focus on here is the art and science of how you secure your company's data in a cloud environment. Fundamentally, it's not that different than the way you would do it in an on-premises environment. You do have a lot more tools available in your arsenal. You have tools from the cloud provider, and AWS and Amazon. Every major backup provider provides services for backing up things. And I think the first thing you kind of want to think about is what is all the data we have in the cloud? Like how much data do we have, and how much of it is just in VMs versus files or storing objects in an object store like Blob Storage or S3. So I think knowing all of that, and it can be really challenging, and this is where taking advantage of some of the automated tools that either the cloud provides or that you get from a third party that look for data that's not protected can be really valuable. It's challenging. So as I mentioned, the security and data security are a shared responsibility between you and your cloud provider. So for example, Azure SQL database, if you build a new database as a service database from Microsoft, your database is encrypted at rest. You have defined a login for it. That's the administrator login that's required for building it. Potentially, you've integrated it with your Azure Active Directory so that users can log in. There's also a firewall, so you can limit the IP addresses that can connect. Or you can say there's no public endpoint at all available, and you can hook it to a virtual network in the cloud. So those are a lot of tools, a lot of different things to think about in the configuration, and that's just one service. As the clouds go, sometimes they'll align services. Like Microsoft has kind of worked to move towards this private link solution for platform services that is a kind of a consistent manner of doing private networking, but it's not implemented in every service yet. And understanding what those different services are the key to having that shared responsibility. And then good security starts with understanding your data footprint. I feel like whenever we do one of these talks, it always comes back to data governance, which is not the world's most exciting topic by any means, but knowing what data you have and knowing where you store it really goes a long way to justifying like the level of investment you're going to spend on securing that data, right? You can't focus on all of your systems. You can kind of do best practices in network isolation, and we're going to talk through some of that. But at the same time, you want to know where the really critical stuff is. Basically, the stuff that's going to get you fined or sued, and make sure that's protected. And you don't want to just protect that. You want to operate in a secure fashion, but you want to pay extra emphasis to that data. And having that understanding can be really, really helpful in terms of just your broader security footprint. Which leads me to my next slide. Governance is your friend. So actually, I was writing a white paper last week when I was writing these slides, and it was on data governance. If you don't understand your data access patterns in the applications, it's much harder to apply security. This kind of ties back into our, like the last topic too, where we were talking about ransomware. One of the things that understanding those data flows and understanding those data patterns lets you do is better observe, better build signal intelligence into, if you have like a threat detection or an endpoint monitoring tool, if you understand those patterns, it's a little bit more easy to detect anomalous data movement, which helps you defend against the type of attacks where somebody's trying to exfiltrate data out of your system. So really good understanding of what data is where and which systems contain what data and how you're going to build that is super, super helpful. And this goes, you can even take this further. One of the things that the cloud avails us to is tagging, right? So, and there are some on-prem systems that allow for tagging. So VMware, for example, will absolutely allow for tagging of VMs, and so you can more easily identify resources other than trying to cram as much information as you can into a 16-character server name. That's really not the best way to do that. But by using a tagging strategy, you can help identify those resources and group them together in different ways. The other thing you can do in some systems is even tag your data. Azure has a system or a service called Azure Data Catalog that will interrogate all of your database systems and data systems, not just databases. And it will attempt to tag your data based on intelligence, and you can append that yourself and enrich the data. So that's a whole lot of options, and it's kind of an expensive tool, but it gives you a pretty good insight into your data. It also makes things like business intelligence a little bit easier. So these processes don't just provide security and data protection, they also give you, a little more insight into your data. If you don't understand those data access patterns in the applications you're using, it's really hard to nail down a backup and availability strategy. This is something I find a lot of times working in my past jobs when I worked at companies, or even working with customers now. A lot of times there's a disconnect between IT and the business, and IT will kind of try to maybe apply a blanket approach to backup and availability. And whenever you try to apply a blanket approach like that, I think you end up with a lesser plan of availability because maybe you're not doing the specialized things you could do for a mission critical system to reduce its downtime and increase its availability. And you're also probably doing a generic backup strategy, which costs more. If you're just saying, well, let's back everything up and keep it for 3 years, if you're doing that by applying a more granular backup pattern, you can definitely reduce your cost. And one of the things that you'll notice if you're not in the cloud yet, as soon as you move to the cloud, cost becomes IT management obsession. And I call that the single bill problem, because now they're getting a single bill every month instead of paying 20 different vendors for various services. So those are the kind of things that are a little bit different in the cloud, and having that understanding is pretty awesome in terms of where you're going and how that works out. So on the next slide, let's talk about the tenets of how we do security. So I kind of broke this down into a few areas, and some of them are basic, some of them are simple. And this kind of ties into data protection, ties into availability, and it ties into networking. So I like to call this the cloud architect's guide to availability, because to me as an architect, I want to consider availability and protection at all of these levels, right? I want to make sure I have a secured perimeter. I want to make sure my network's split up so that if somebody user does click on a phishing email, it doesn't impact like the production servers, because we want to limit what can talk to what. MFA, we'll talk about MFA when we get there. You should just be using it. And I'm going to yell a little bit. Encryption, that's handled a little bit differently in the cloud. We want to talk about that. Encryption is good, but you also need to have a strategy around how you manage those keys, because it's all well and good to encrypt your backups, but if you don't have the keys or they're not backed up properly, you don't have backups. You just have a pile of encrypted data. So we'll talk through that in some scenarios there. We'll talk about backups and then the strategies I like to implement. And we'll talk about high availability and trust. So perimeter security, and we talked about this a little bit earlier, but this is who has access into your cloud environment. So I like to think of this when you first start thinking about your cloud, when you're first building out your cloud environment, and this goes for any cloud, the list of people who need to have access to the cloud control plane should start out with the list of people who have access to your data. If you had a physical data center, the list of people who would have access to that data center. It's going to probably expand a little bit because it's a little bit broader audience in IT, but that's definitely the initial audience. Then you need to think about other things that need access. So this is going to be automated build processes. So if you're using CI/CD pipelines, where the pipeline is actually pushing code into your apps, those are going to have a way to authenticate and push code into your various cloud services. So whatever vendor you're using for those solutions, you need to think about. You also need to think about the people who are going to need that access, identities, and how you want to group them. So in Azure, there's a concept called resource groups that I like to really use as a unit of security. Amazon has a similar feature, but I'm not remembering the name of it off the top of my head right now. But you use those groupings of resources that you build as your security boundary, and that's how you can control who has access. In order, both people and services have identities, and in your cloud security model, they're going to be treated somewhat similar, and you assign specific roles within the cloud to those identities, and that's kind of how this works. You can obviously use role-based access control. You can grant permissions to roles. You can even grant roles to roles in some clouds. One of the last things on this slide too, and I brought this up because I brought up CI/CD processes, but it's important to have some foresight into what you're building and supply chain attacks. So, like the SolarWinds attack happened this year because there was a bad DLL in the code. I'm still not 100% sure how that got there, but one of the things you want to look at evaluating from your security perspective is a tool like on the container side. I know there's a tool called Qualys that will check your containers for malicious code. Potentially, you can even look at something like that to check your code. I'm sure there's something in the space, but to validate the checksums in your code, just to make sure that there's no malicious third-party packages as you're building custom software. That's really hard to manage, especially with like nation-state attacks, but it's something you can mitigate against slightly. And well, it's one of those things like we talked about. You're always going to have vulnerabilities, right? But if you can reduce some of the vulnerabilities you have, you're less likely to be attacked, because a lot of times attackers are going for the easiest target. So reducing those vulnerabilities can be really helpful. Networks. One of the things I really like about cloud computing, and this is kind of true on-prem, but you have to have a lot of third-party stuff to do it, and it's not something that I've seen nearly as commonly, is all the networking in the cloud is virtual. Obviously, you're not going to call Microsoft and tell them you want fiber run between these two racks of servers, or we need a new top-of-rack switch. Everything is virtual, and everything is defined by software. And that's wonderfully helpful because we don't have to do as much physical stuff if we want to change things. So if you didn't have great security today, it's not necessarily a 12-month project to rerun wires in a data center to fix it, or to touch 100 switches. It's a lot easier to segregate things. One of the things that gets really challenging, though, is as your teams use a lot more platform as a service offerings, and this can be serverless things like Lambda functions or Azure functions or logic apps or automation or databases, like I mentioned, that are inherently, they're not necessarily serverless, but they're things that have public endpoints. The Amazon storage or the Azure storage I mentioned earlier, those all have the potential to have public endpoints. One of the things you want to evaluate is, can we turn off those public endpoints? Do we need to make anything publicly accessible? Ideally, you want to segregate as much as you can. Anything that's internet facing, you want to put either into its own network or into its own subnet where you can heavily port restrict it. You can potentially firewall the traffic in front of it. You have lots of options as to how you can do that, but you need to understand all of those endpoints. You also need to understand, what platform services your team is using and how those affect security in your security footprint. There are a lot more opportunities to have public endpoints into your services. I think every service I just named as a platform service has the potential to have a public endpoint. And they all have firewalls, and they mostly all have private networking that they can be connected to now, but a lot of times by default, they're going to deploy in that fashion. So it's important for you to have, staff who understands those things and can quickly identify it, or tooling from the vendor that warns you that, hey, this database is open to the entire world IP address range, which isn't a good thing. The other thing that I mentioned, and this really kind of jives with the ransomware thing, is network segmentation is easier in the cloud, but at the same time, it's more important. Because it can potentially, because of the kind of breaches we're seeing now with ransomware attacks, you really, really want to have your traffic segregated. And I saw this with a client recently where they were attacked, and what they ended up doing was they run in a hybrid fashion, and they were able to kind of quickly disconnect their cloud environment from their on-prem environment, so the scope of the attack was limited. But that's not really the best way you want to do that. Ideally, and this unfortunately doesn't work with all applications. There are a lot of legacy applications that have either fat clients or potentially web clients. You really, really, really want your client PCs, so the end user PCs, not to be able to communicate directly with your server subnets. They only need to be able to go over certain ports, and even that traffic can be limited. Isolation is really the best thing you can do. What you want to do is, if you have an attack to a user machine, not have that attack your servers. So I always tell people, if you can remove desktop into one of your domain controllers or one of your SQL servers from your machine, your network isn't designed super well because attackers can do that. So having those things all separated, only allowing traffic as needed between server subnets, and only limiting the ports, those are all excellent things to do. They're hard. Everything that's good in security makes your life harder. Having worked at one of the cloud providers in support of some production stuff, security was like a complete pain. It was really hard to do stuff, but they were secure. So knowing all that, you really want to look at your network segregation, and that's definitely something. If you're worried about a ransomware attack, that's something you want to look at. The other part of this is you can use policy in your cloud, and these policies in the cloud sort of work like a group policy. And I know there's some third-party tools that do this too. I'm a little bit less familiar with AWS in this particular space, but Azure has policies and initiatives and blueprints that allow you to define the types of resources that can be applied. You can define policies that don't allow resources with public endpoints to be deployed. There's a lot of good stuff that's just built into the platforms that lets you build a more secure environment. You can also kind of use those things for cost control too, so you can kind of limit the types of resources that can be deployed or the sizes, and you can even limit the regions where they're deployed. This is going to be pretty short. MFA, this slide, I did make this slide in all caps, and this slide is a reminder for you to use multi-factor authentication if you aren't already. Yes, you should use it for any account that supports it. Yes, I am yelling at you. Good security is harder, and this is one of those things you kind of just have to blame the bad guys for, right? This is something we have to do now. And just to take this a couple of steps further, because we've seen a recent attack where somebody's cell phone got hijacked too. If you have the option on any of your accounts to not use SMS or calling for your multi-factor authentication, do that. The app-based authentication is more secure. And I implore you, anywhere you can turn on MFA, do it, even in your personal life, for your bank account, for your cable provider, for your thermostat, any of those places, it's a good idea to turn on MFA. And like I say, you probably want to avoid the text message thing. It's better than nothing. But the app-based authentication is just kind of easier to deal with anyway. But it's also way more secure. So encryption, we ran into this kind of, we had a customer thing last week where we ended up having to restore a backup of something, and it ended up being a non-issue because the servers had the certificates but we kind of had to do a runaround because it was a company, our client bought another company, and that company's staff had left. So we were kind of scared for a little while that we weren't necessarily going to have the certificates and passwords to back up or to do a restore to a new environment, but we did, and it was okay. But that's something you really need to think about, like encrypting data and how you encrypt data and at what level you encrypt data. Encrypting data in databases is pretty hard. The tools are there to do it. Like Microsoft makes it pretty easy. Oracle charges you money. There are third-party packages for MySQL and Postgres. But that part of the process isn't that hard. The part of the process that's hard is rewriting your application code to deal with that encrypted data, and that's where we see a lot of customers fall down. The cloud doesn't make that part of data encryption any easier. It makes it a little bit easier in that they give you a place to store their certificates, and you can reference the key vaults and things like that. But it doesn't make writing applications to deal with encrypted data any easier. You still have to update your client libraries to deal with that encryption. It's more efficient. Like Microsoft has made it way easier with always encrypted, but at the same time, it still requires application change, and that's developer time, and you know how that works. One of the things the cloud does, and I'm not a crazy fan of this service, but encryption at rest does become really easy in the cloud. In Azure and I think AWS now as well, all disks that get created for VMs are encrypted at rest by default using a service managed key, so you don't even have to worry about the key. Azure manages it for you. There are also services that provide ways, if you want to use your own certificates, that you can secure secrets and certificates. Take advantage of those. And Azure, it's Key Vault is the main service. Amazon has another service I don't remember the name of. The other service that a lot of people use is HashiCorp's Vault to store secrets. Those services are really good. They add a lot of functionality. They keep you from storing secrets in code. These are all good things in terms of protecting your data because every one of those things is a vulnerability. One of the things I know Key Vault offers in particular, they have a way you can hook up with your certificate provider, and they'll help you rotate your certificates for various reasons because those certs expire. And that's kind of a really, really handy thing because we all know that certificate expiration is kind of a problem. The big thing I want you to take away from encryption is your stuff's probably going to be encrypted at rest in the cloud by default, so you don't have to worry about that. Encryption at rest per se doesn't really buy you anything in the cloud other than making your auditor happy. You really want to think about the data, who's accessing the data, and can they retrieve unencrypted data. So the dreaded scenario is always somebody connecting to a database with Excel, downloading, the customer list into Excel, and then running off with it. So you want to think about that scenario, and do you have monitoring for that? And moreover, if you could just encrypt the column of customer names, and only the application would have the key to decrypt it and not Excel, then you dramatically reduce the likelihood of an attack like that. Because when this disgruntled sales rep connects Excel to the database, he's only going to get a collection of ciphertext. He's not going to get any real customer data. So those are all kind of important things to think about from an encryption perspective. The final thing I'll tell you is I know a lot of organizations have a requirement to manage their own certificates and deal with that. If you have that requirement, by all means, do that. If you don't, I recommend letting the cloud provider manage them. It's just easier and more efficient. And if you don't have that requirement, if you have a requirement like that, you tend to have a lot more IT staff, so you probably have somebody who can look at that. Whereas if you're smaller, you're probably better off just letting the cloud manage it. So one of our sponsors today is the cloud backup provider, or our sponsor today is the cloud backup provider, and there are a lot of backup solutions on the cloud. If you just go into, the Azure or Amazon marketplace and search for backup, you'll see a myriad of solutions. Additionally, both clouds support robust native backup solutions as well. It's important to understand what systems and data need backups to optimize your cost and data security. So What do I mean by this? Basically, you shouldn't have to back up as much stuff as you think you should, although you might have a regulatory requirement to do it. But things like web servers where you're just pushing code into an IaaS server, that's something that you should be able to redeploy and not do a restore on. Any kind of infrastructure that's just there and has code pushed to it is something that you can integrate into a build pipeline. You can define that infrastructure as code and reduce your backup cost. It's not that, backup is going to be your biggest cost, but when you start talking about, backups, and especially if you're keeping them for a long time, it can add up to a sizable portion of your cloud bill. And it's not that I think it's bad to back up data. Backups are your most valuable thing. It's really, don't back up stuff you don't need to back up. I mentioned earlier, if you can push database backups into cloud storage, there's not a whole lot of reason to back up that server after you do that, because you can get a new server really quickly. And that's one of the things about the cloud and data protection is you kind of have to think differently. So that's something you want to think about. The cloud, Azure and Amazon both provide long-term backup storage at a cheaper rate. There's even, Amazon has Glacier, Azure has archive storage. Those are things that are designed to really just store data, and the pricing model is it's really cheap to store data. It's pretty expensive if you have to restore it on any sort of regular basis. So I'd like to recommend those services for when someone else tells you that you have to have backups for some period of time, like the federal government. I know I worked for a medical device company that had some legal issues, to say the least. And one of the things they were able to do is we had to keep all of our backups forever. And at the time, the cloud wasn't a thing. But now having those low-cost storage options, I think they're like a penny a gig a month, are really good for those kind of backups. Another thing is understand the security of your backups. And this is a good discussion to have with whoever your backup provider is, whether it be Amazon or Microsoft or whether it be a third-party solution. You want to understand how those backups are stored and how they're offline. And this really hooks into our ransomware discussion earlier. You don't want somebody to be able to hijack some credentials, get into your Azure portal, and then delete all of your backups. So for example, just one of these features, and this is a really basic one in Azure, soft delete is turned on by default for your backups. And if you turn it off, it doesn't actually turn off for 14 days. I ran into this the other week because I was trying to delete something. And what that protects you against is theoretically, well, you should have an alert on that will yell at you if somebody turns off soft delete. So you could catch that before they could delete your account. It's important to understand the methodology for that. It's also important that your backups be immutable. You don't want anybody to be able to write over them, which is what ransomware does. They should be write once, read many. And you should understand how your platform as a service offerings are backed up. Different types of cloud services have different types of backups, and they have different needs. Like your web application probably doesn't, even though it may have a backup solution, it doesn't necessarily need it. Your database needs to be able to be restored to a point in time. Finally, you want to understand how your email and chat services, especially if you're using software as a service providers like O365 or Google Suite, are backed up. Typically, you're going to need a third-party solution to do that. The vendors don't guarantee point-in-time restoration, so you want to understand that. So high availability. One of the things that's kind of interesting about the cloud is a lot of our customers who have moved there experienced a higher level of availability their first year in the cloud without doing anything special, with using standalone machines than they had on-prem. And this is just the platforms are really robust. Azure, I think, offers 99.5 availability for a single VM. And honestly, in their data, they've mostly gone beyond that in terms of what they've hit. So it's pretty strong. But the easiest way to think of the cloud is just like VMware or Hyper-V, where if you have a host fail, your VM is going to move to another machine. So you can have transient outages, but it's important to understand that. So you need to just understand how your application stack deals with failover, what its criticality is, and how you're going to manage that. The kind of failures you should really plan around are a cloud region going down, but not necessarily the entire cloud going down. There are also some disaster recovery options in the cloud. So like Azure has Azure Site Recovery, which lets you fail to another region or even do test failovers. And additionally, there are some some third-party providers that provide similar solutions that you may want to look at. So trust. Don't trust anyone or anything. One of the things you need to do is limit your blast radius for a data breach or an application failure. So you want to limit how one system can impact another, and that's by doing network segregation, limiting roles, only using privileged identity management, so you're heavily automating administrative stuff. And you want to take advantage of cloud tools and recommended best practices. So the security tools that will tell you the good things to do, those are important. And you should understand what you need to do versus what you need to buy. So there are certain things you can just do to build a strong security posture, and there may be other things you need to buy to help accelerate that. And classic build versus buy decisions, but they come at you a little bit faster in the modern world. So to close out, understanding the nature of your data and where it is allows you to better construct a good data protection strategy. Your control plane to your cloud, whether that be the AWS console or the Azure portal, that's like your data center, and you need to really treat that as such and think about it that way. Locking down your network, your best friend in the event of one of those unfortunate ransomware attacks, and having good backups, and more importantly, having a strategy where you can easily test the restoration of your backups on a normal basis is by far the most important thing. Because if you get attacked, if you have a user or a developer who writes some really bad code, those backups are going to be what's going to protect you from that. And thank you, everyone. And let's pop over to David for the Q&A.
Okay, great. Thanks, Joey. I'd like to remind the audience that we can answer questions until about 5 minutes to the top of the hour in order to give you a short break before the next presentation, so send them on in. And let's get right to it. First question reads, what are some best practices for locking down your cloud control plane?
So first of all, turn on MFA. In case you didn't get that message from my slide, turn on MFA. Limit the number of people who have access directly. You may have your whole directory synced, but that doesn't mean anybody has to have permission in the cloud. So you want to really limit the groups that have access. And then thirdly, you can use things like privileged identity management or conditional access to kind of, maybe limit where they can connect from, or if you want to go really extreme with privileged identity management, an admin has to escalate and justify doing work, and there can be an approval process or at least a logging process. Those are all kind of good things to do in that environment.
Okay. Here's a question from Adam. We're currently handling backup of email and SharePoint in Office 365, but we are not backing up audit log data. Do you have any recommendations on how to make that data available longer than Microsoft provides it?
I don't. Off the top of my head, I would ask Microsoft so most of that data is logged in Azure, but it's kind of hidden from you. But in a lot of cases, they'll have, in Azure in particular, they'll have ways you can ship that data to Log Analytics, which is their log handling platform. I would look in that direction, but I would also talk to third-party vendors too and see what your vendors tell you. Because presumably you can pull it. That's not the ideal way. Microsoft pushing it into Log Analytics would not be a terrible solution.
All right. Next question. Can you explain conditional access and privileged identity management? I know you touched upon those, but maybe you could recap in general.
So conditional access would mean if I wanted to say, I'm just going to throw out a random IP address. If I wanted to say only users coming from 192.168.1.10 can connect to are allowed to connect to my portal, and they have to multi-factor authentication to access that. That's like conditional access. You can also say only users coming from the U.S. can connect, or you can even potentially define conditional access based on what's running on the device. So conditional access is basically saying who you're going to allow to connect and what you're going to do to authenticate them. Privileged identity management is a little step beyond that. There are a number of ways about this, but the easiest is if Joey, like at DCAC, I have joey@dcac.com, and I have an admin account that's like adminjd@dcac.com. For me to get effectively with privileged identity management, admin JD would be turned off until I made a request to my manager or one of my peers to approve that I need access to that account for 30 to 60 minutes. And I would justify it. And there are a lot of controls around how much control you have on this. But that means it's harder to get in, and you have an audited path of who are the admins going in. It's painful, but it's really effective security.
Okay, great. I'd like to remind the audience we have plenty of time for more questions, so send them on in. And here's one from Chandon. He says, do you think AWS WatchGuard MFA is enough to secure the AWS console access, or do you think anything else we should consider in addition to it?
I haven't used WatchGuard. All of my customers that use AWS use Duo, use Duo in conjunction with Okta. So it's like some combination of the two. I don't really have any endorsements in that space. I work a little bit more with Azure, and my customers there typically use the native stuff. But any of those solutions that force a multi-factor authentication are good. What you want to consider is, can you limit the IP range that people are connecting from as well as part of that?
All right. There's another question about something you addressed, but maybe you can review a little bit. How do you manage access to different cloud accounts or subscriptions?
This can be a little bit challenging because as you get bigger, you have more stuff. So like even at DCAC, a small 7-person consulting firm, we have 6 Azure subscriptions, and you can use a subscription as a security boundary, or an account in Amazon. In Azure, there's ways to manage those cross-subscription security. So like you can apply the same security at all your subscriptions. Amazon has a little bit similar functionality, but really it's a challenge. And the big thing is to have unified management. And where this gets really bad is if you have accidental multi-cloud, as I like to call it, which happens when some department goes off and does their own multi-cloud, and the centralized org doesn't know about it. As long as you're managing things centrally, it can be pretty efficient. But I think when you're thinking about identity management and things like that, you don't want to trip yourself up and think too differently from on-prem, because you're really kind of talking about fundamentals.
Okay. Someone is wondering, what about cloud computing makes things easier for firms in regard to data protection? Is the cloud inherently more secure?
The physical security of the cloud is inherently more secure. The cloud makes things more accessible because a lot of things that were either really expensive because you had to buy them as hardware appliances or you had to implement them yourselves are kind of fundamentally baked into the architecture of the cloud. Like some of the just networking and segregation things are just a lot easier to do in the cloud than they would be in an on-prem world. And I think that's where it gives you, I'm slightly hesitant to say inherently more secure, but I kind of agree with that it is, because like you just have a lot more tools available to you right there, and some of that logic is just built into the solution.
All right, great. Here's a question from Brian in the audience. I'm not sure if he's talking about AWS or Azure or both, but the question reads, is OAuth or FIDO2 supported?
I do know on the Amazon side, well, Amazon uses OAuth. I think they have a FIDO2 option. I know Azure Active Directory does for sure. Azure Active Directory is inherently OAuth, but they also support FIDO2 as a methodology for authenticating.
Okay. Here's another very general question. What are the very first steps we should take to protect our data as we move to the cloud?
The very first step you should take is to make sure that you have a secure network connection between your whatever your on-prem environment or your office is and your cloud. Then do identity, then go back and look at your network again, and those are the two main things. And then look at like the actual security of what you've ran in your cloud. But that's from a security perspective. That's where I would go.
Okay, looks like we have time for about one or maybe two more questions. This one looks like it might be coming from the standpoint of a consultant, like if you're a consultant. What are the first things you look for when assessing the security of a customer's cloud environment?
So the first thing I look for is to make sure they have MFA. The second is public endpoints, and then the third is really high privileges. So those are kind of the top three, like access control, like, what's authentication, not authorization. Then what's publicly accessible and why. And then finally, who has what authorization. And those are the big three. Obviously, it goes down to more granular from there, but that's what you want to look at first.
All right, last question. How does the cloud change your backup strategy?
It puts a price tag on it. I think it makes me think about it makes me think about, do I absolutely need to back this up, or can we rebuild this? The big thing, and the point I was trying to make with all that backup talk is it's really fast to deploy new resources in the cloud. That's one of the major strategic advantages is the flexibility. And if you can deploy a new resource, put your code into it, and have it running, that may be more efficient than backup, rather.
Okay, cool. Well, that's all the questions we have time for. Thanks again, Joey, for an excellent presentation and answering those questions.